Question number 3. So the figure is showing a bead executing a simple harmonic motion with a period of 1.8 seconds along a straight line between point X and Y, which are 25 centimeter apart. So point O is the midpoint between X and Y where the simple harmonic motion starts. So what we need to do is we need to write an equation for the displacement of the bead. So the bead is here. Is it that one? Yeah, okay. But so this is basically dia punya motion. So what we can get from this figure is as O is the midpoint, this is basically telling us that the amplitude is half of this 25 centimeter. So A is gonna be 25 divided by 2, which is basically 12.5 centimeter. So that is 0.125 meter. Kan? Yeah. 1, 2, yeah. So next, what do we have? The period. So the period is given as 1.8 seconds. So we just have to write an equation of displacement for the bead. So we know that the general equation is A sine omega t. So we have A, we just have to find the angular frequency. So the angular frequency is 2 pi over the period. So that is 1.8. So you get the angular frequency to be equal to 3.49 radian per second. Ataupun if you don't want it in point, actually it's better that way. If not, it will be 10 pi over 9. So if some of you uses pi, it's gonna be 10 pi over 9 radian per second. So it's up to you whether you want it to be in 3.49 ataupun 10 pi over 9. Okay, so sekarang ni kita just substitute lah dalam this equation, the general equation. A is 0.125 sine 3.49 t. Okay, so define ataupun declare dia punya unit. So where y is in, what is it, meter, t is in second. Okay, next we have to calculate the magnitude of velocity and acceleration of the bead at point P. So at point P, y is equal to berapa? Y is equal to 0.125 minus 0.05. Okay, so but we are measuring the distance from the equilibrium position. It is not from here pergi di sini. It's not 5 centimeter. It will be y equal to 12.5 minus 12.5 minus 5 centimeter, like 2 centimeter. Okay, so let's do the equation. So we know that velocity is omega a square minus y square. Okay, so y is equal to 0.125 minus 0.05. So that is equal to 0.075 meter. Okay, so substitute lah the values. Omega is 3.49. A is 0.125 square minus 0.075 square. Okay, so V is equal to V at Y equal to 0.075 is equal to 0.349 meter per second. Okay, so do for acceleration as well. So acceleration is basically just omega square y. You can add the negative if you want to. Just remember that the negative is just telling us about the direction. Okay, so direction to maksudnya direction of acceleration is always opposite to the direction of displacement. Macam tu maksudnya. Okay, so I choose not to add the negative just to prevent any confusion on. Okay, so this is 3.49 square. Y is equal to 0.075. So this will be equal to 0.914 meter per second square. Wow, kuat juga hujan nih. So question C pula, we have to calculate the positions along the xy when the kinetic energy and potential energy are equal. So untuk soalan macam ni, you just have to declare lah kinetic energy is equal to potential energy. Okay, and then what? And then we are gonna use the formula. Apply lah formula kinetic energy. So kinetic energy is m omega square a square minus y square equal to half m omega square y square untuk potential energy. So dari sini we can cancel a few things, which is this and this. So we are basically left with a square minus y square equal to y square. Okay, so rearrange for y. It's gonna be a square divided by 2. So kamu akan dapat the position where k is equal to u is when y is equal to 0.0884 meter. So why is it positive, negative? Because remember, we have the positive side, then we have the negative side. Kan dia dari equilibrium. So this is going to be the negative side, this is going to be the positive side. Okay? Alright, so that is on question number 3.